All right, welcome back. We're going to continue in on section 6.5, definite integration with u substitution. Today we're going to focus in on the e's and the natural logs, our fun favorites. So let's go ahead and look at the example 1 here. We're going to integrate from 1 to 2 of 1 over x plus 1 dx. Again, we could bring that x plus 1 to the top as a negative exponent. Gives us a quantity to an exponent, so we're going to let our u be that quantity, or x plus 1, the denominator. Our du is going to be dx, so we should see we have a nice clean integration here, substitution. So if I plug in my 1, again remember these are x values, we're going to plug them into our x's over here to change them into u's. So if I plug in 1, I end up with 2, and if I plug in 2, I end up with a u value of 3. I'm going to do my substitution, 1 over x plus 1. X plus 1 actually was u du. Integration, I know the integration of 1 over u is the natural log of the absolute value of u from 2 to 3. Again, I can plug in my 3, plug in my 2, and subtract the two values. So the natural log of 3 minus the natural log of 2. And that would be an acceptable answer. Or if you want to go ahead and put it in your calculator, natural log of 3 minus the natural log of 2 gives us approximately 0.405 as our answer. And we're done with that one. Example 2, we're going to look at an e. Remember, when we have a single e, we're going to let the u be that exponent of e. So now we're going to go ahead and find the derivative here. Du is going to be 1/2 x to the negative 1/2 dx. We have a square root of x in our denominator, and if we were to rearrange this, we could write this as 1 over 2x to the 1/2 dx equals our du. So we do have that x to the 1/2 on the bottom, or the square root of x. We don't need this 2, though, for our integration. So we're going to bring that 2 back over with the du. So 2 du's is going to equal 1 over the square root of x, or x to the 1/2 dx. So now we're integrating. I'm going to plug in my 1 and my 3. Again, these are x values. I'm going to change them to u values. Square root of 1 is 1, and then we have the square root of 3. 2e to the u du. Again, remember, we had to bring our 2 in with our du to get rid of that square root of x in our denominator. Integrating, we know the integration of e to the u is e to the u. So we have 2e to the u from 1 to the square root of 3. Plugging in our values, we're going to have 2e to the square root of 3 minus 2e to the first. Again, we definitely can put this in our calculator if we wish. We have 2e to the square root of 3. Nice ugly number there. Minus 2e to the first, which gives us approximately 5.868 as our answer. Just a couple more examples here to go through. Again, a natural log and one with a couple things happening with it. So in example 3 here, we have a natural log of x. Remember our u, when we have a natural log, our u is generally going to be that natural log function. So in this case, we're going to let u equal natural log of x. Du then is 1 over x dx, which is nice because we have the 1 over x dx in our integrand. So we're going to go from 1, the natural log of 1 is 0. If I plug in 2, again remember these are x values, I'm changing them to u's, I get the natural log of 2. So now I'm going from 0 to the natural log of 2 of u du. The integration of u is u squared over 2. We're going from 0 to the natural log of 2. Plugging in the natural log of 2, as the natural log of 2 squared over 2 minus 0. Again, I can put that into the calculator. So I have the natural log of 2 squared divided by 2 gives me approximately 0.240, or just 0.24. And our last example, example 4. We see that we have e's in there, and we also have a 1 over x. We're subtracting two functions from each other. So what I'm going to do is I'm going to break this function up. So I'm going to integrate from 1 to 3 of 2e to the 2x dx. And from that I'm going to subtract the integration of from 1 to 3 of 1 over x dx. The reason I'm going to do this is because I know the integration of 1 over x. I don't know the integration of e to a quantity or to an exponent that's not a single variable. So I'm going to use u substitution on this first part. I'm going to let u equal that exponent of e. So I'm going to integrate. Now instead of going from 1 to 3, I'm going from 2 to 6. The derivative here, I probably should have found the derivative first there, but du is going to equal 2 dx. So I got the 2 and the dx in my integrand, so I'm going to look at the integration from 2 to 6 of e to the u minus, and I'm going to keep this integration from 1 to 3 of 1 over x dx. Because I know, again, remember, the derivative, or the integration of 1 over x is the natural log of x. So here, I have the integration of e to the u, which is e to the u from 2 to 6. I can integrate this. The integration of 1 over x is the natural log of x from 1 to 3. I'm going to go ahead and find now my value. So I have e to the 6th minus e squared minus, I'm going to put this in brackets. So I'm going to take the net, because I'm subtracting. I'm going to plug 3 in, so I have the natural log of 3 minus the natural log of 1. So now I can go ahead and throw this into the calculator if you want the exact value. So I have e to the 6th minus e to the 2nd. And from that I'm going to subtract the natural log of 3. And then remember the natural log of 1 is just 0, so we don't have to really worry about that. So this gives us an approximate value of 394.941. And that's going to conclude our integration with e's and natural logs. Happy integrating!